Hello students, we are going to discuss about nanomaterials and nanotechnology. So this is a first module in your syllabus in the semester and going to the brief about things that will be discussed in this session. That is, in brief, it is an 8-hour topic and you will be having an introduction to nanoscience and Moore's law will be discussed in brief. And various properties of nanomaterials will be discussed, and we will be having a small discussion on synthesis of nanomaterials by various methods like reduction, precipitation, Sol-Gel method, etc. And we'll be coming across the green synthesis of silver nanoparticles and gold nanoparticles. And one of the important properties of nanomaterials or metal nanoparticles, that is surface plasmon resonance, will be discussed in brief. And one of the important technique by which we characterize nanoparticles, that is TEM, which is transmission electron microscopy, will be discussed in a brief. We won't be going in depth into the TEM methods, but only a brief discussion on TEM will be given. And after this session, after the module, you'll be having elementary idea on some of the nanoparticles, that is carbon nanotubes, fullerenes, quantum dots, etc. And in the end, we'll be looking into the properties and applications of nanomaterials, nanocomposites, and nanomedicine. So, before going further, this actually is a very important field that is emerging, and this field actually has very important applications in our day-to-day life. If you are looking into various things that you're using, or if you're wearing a scratch-free or scratch-proof glasses or wrinkle-free t-shirt, there will be some influence of nanotechnology in those things. So nanotechnology will be around you without you even knowing. So this actually is a very established field, and still now there is many research going on in this field, and which is a very promising field, and moreover anything, it is a very interesting field of study. So by definition, nanoscience and nanotechnology refers to the control and manipulation of matter at nanometer dimension. So when you say nanotechnology or nanomaterial, what is actually this nano that you're meaning? That is, we are talking about something that is happening at a 10⁻⁹ meter scale. It would be easier for you to understand at a 10 centimeter scale or 1 centimeter scale, or even 0.1 centimeter scale. Beyond that, it would be difficult for you to imagine the events and processes that are occurring at 10⁻⁹ meter scale, that is nanometer scale. So in nanotechnology, we will be focusing on processes of materials at a scale of 1 to 100 nanometer size. You should be able to imagine how small that is. But this particular scale or this particular range is very important in the sense of biology and in many applications in our day-to-day life. So just to brief, we must be familiar with some of the practices of some of the nanotechnological applications that are used in various fields. One simple example is, even in the ancient times, the nanotechnology have been used. And the simple example is, in Ayurveda, you'll be using some medicines that incorporate gold in it. So this is actually pointing towards the application of gold particles in the nanometer scale in our medicinal applications. So nano gold will be having some medicinal properties. Or in your cosmetic products, some of you will be using cosmetic products or sunscreens or some kind of things. You can find silver nanoparticles or some kind of titanium nanoparticles. So in many fields or many products that you are using, there will be nanomaterials. And there is a particular memory enhancement medicine that is given in Ayurveda, that is Saraswatarishtam, which uses colloidal gold in its preparation. And in this figure, you can see a cup which is having two different colors. This is due to the presence of a particular nanoparticle, and that nanoparticle is gold nanoparticle. In the presence of light, this green colored glass will be looking like a red colored glass. That is, the glass contains colloidal gold nanoparticles, and in the presence of light, it is having a particular optical property so that it will be giving out red color. So details regarding this optical property, optical phenomena will be discussed further in this module. So this is actually a cup that was prepared by Romans in 4th century, and this actually points to the fact that even in ancient times the nanomaterials were used for decorative as well as many other processes. So even though the nanoparticles or nanotechnology were used in ancient times, a real focus or real interest in nanotechnology arose during or after 1959. In 1959, Dr. Richard Feynman, one of the greatest minds in history, he actually delivered a lecture titled "There is Plenty of Room at the Bottom." This lecture actually gave the idea of manipulating atoms and molecules at a nanometer scale, at a very lower scale. He actually inspired many minds why it is not possible or why it is not tried to manipulate individual atoms in that particular scale and create new and new materials. So after his lecture in the American Physical Society meeting at Caltech, many scientists came forward and many scientists tried this concept, and this actually paved the way for the development or the birth of nanotechnology. So nanotechnology is actually a magical field or magical dimension scale. The structures in nanoscale are considered at the borderline of smallest of human-made devices and the largest of living system. So this is actually can be considered as an interface between man-made and living cells. The ability to control and manipulate nanostructures will make it possible to exploit new physical, biological, and chemical properties of the system. So, if you are wisely using nanotechnology, we can actually create wonders. Now, why is nanoscale very important? This is a very important question. So, in nanoscale, you will be manipulating atom, and in this particular regime, the quantum mechanical properties will be very much active or very much pronounced. So quantum mechanical properties of electrons inside the atom will be very highly influenced by the variation on nanoscale. If you are changing any property or surface or size by a very few points, even very small points, you will be changing the entire properties of the material. So easy manipulation at the molecular level or easy manipulation is possible at this particular scale. And second thing is that it enables the incorporation of nanoscale devices in the living cell. So in our living system, we can incorporate various medical devices, and for the fabrication or development of these devices, we require systematic study and expertise in that particular, in a lower dimension. You should be able to manipulate the atoms in the lower scale. And if you are able to manipulate the atoms in the lower scale, you can actually prepare devices that can be incorporated into your systems. And Nanotechnology or nanoscale is actually important due to this particular concept. And the third thing is that in nanomaterials will be having very high surface to volume ratio. And due to this particular property, they can be used for various applications such as drug delivery, energy storage, etc. So, in nanomaterials or nanotechnology, the important property is the surface to volume ratio, one of the important properties. And due to this property, we have various applications for this particular nanomaterials. Now, coming to the characteristics of nanoparticles, as we mentioned earlier, the first and foremost characteristic of nanoparticle is the large surface to volume ratio. You should not confine your concept of nanoparticle to a spherical something. It can be linear, rod shaped something. It can be some other structures. So any structure you are considering, it will be having large surface to volume ratio, and it will be having high percentage of atoms or molecules on the surface. And surface forces will be very important than the bulk forces, and they will be having unique optical and electrical properties. And one of the important class of the compounds like quantum dots will be having very much applications in our daily devices due to the optical and electronic properties, and they have unique chemical and physical properties, and their size is similar as biological structures, and so they will be much more useful for many biological applications. So this is a simple work that you have to do by yourself, and you should not be showing me what you have got, but just try to look around you and find what all nanomaterials have been used in your day-to-day life. So if for a simple example, if you are using a wrinkle-free shirt or a scratch-resistant sunglass or the camera in your phone, when you're using phone, or in many applications you can see there will be some kind of nanoparticle, or if you're even watching television, there will be some kind of nanomaterial. So look around you and try to find out what all materials or what all nanomaterials are uh, directly in your life around you, that is being used by you. So, and what is the importance of that material, what is the importance of using that nanomaterial in that particular system. So try to look into that and understand something about the nanomaterials that you use everyday life. Now we are moving on to one very important, very interesting topic. Not very important, it's so important. So this actually points to the importance of nanotechnology. So we know that transistors are one of the game changers in computer technology, and before the invention of the transistors, we had very large computers, which had very high weight and all. But nowadays, the computers are having very small size, and you are even able to handle that with your single hand. And this particular achievement was due to the due to the nanotechnology reasons. So, what is a transistor? Transistor is a semiconductor device used to amplify or switch electronic signals and electric power. The discovery or invention of transistors revolutionized the field of electronics and paved the way for smaller and cheaper radios, calculators, computers, etc. The transistor count is the number of transistors in a computer, and it correlates to a computer's performance. If you're having large number of transistors, that means the computer will be very fast and very efficient in calculations, as well as it will be much cheaper. Uh, the transition count is usually used to refer the number of MOSFETs, that is metal oxide semiconductor field effect transistors that are present in the circuit. They also referred to as MOS transistors. So as the number of transistors increases, the efficiency of the computer increases and the cost will be reduced. So here you can see the first generation computer, that is ENIAC, that is electronic numerical integration and computer, that weigh about 30 tons. It doesn't had any transistor. It used only vacuum tubes. And in the right side you can see a computer, a laptop that is being used nowadays. So you can actually compare the size difference between these two systems. So the introduction of transistors actually paved the way for this entire change. The use of transistors, however, changed the scene completely. The transistors enabled in building efficient and smaller computers. The silicon transistors revolutionized the computer design. As mass production of silicon transistors was realized, computers became more cheaper. And modern silicon transistors that we use today are very small, that is much smaller than 45 nanometer, which enable their incorporation in the computers. Even billion numbers of them can be introduced or used in a single chip. So by use of nanotechnology, lithography, etc., we were able to develop transistors which are having very small size, the nanometer size. And another important feature was that these transistors were easily incorporated in a single chip. Even millions can be easily incorporated in a chip, and this actually provided high-speed computers as well as smaller size computers. So these transistors actually paved the way for a change in computer technology. Here you can see a comparison between the ENIAC and Intel Core Duo chip. And ENIAC was introduced in 1946 and Intel Core Duo chip was in 2006. And the performance, you can compare the performance. ENIAC could perform 5,000 addition problems per second, and the Intel dual core could do about 21.6 billion problems per second. And the power usage is very much different. Weight, the ENIAC weighed about 28 tons, whereas the Intel Core weighed negligibly. Size and everything is different, and you can see the cost, how much cost is reduced when you change to Intel. So this all point to the importance of transistor. So in computer technology, transistors paved a way for revolutionary change, and the development of these transistors were made possible due to the nanotechnology. So you were able to miniaturize these particular materials, devices, and you were able to achieve more and more efficiency. So this is an important law in semiconductor technology, that is the number of transistors per square inch on integrated circuit doubled every year since integrated circuits was invented. So the Moore's law is an important law in this field, and this is named after one of the co-founders of Intel, that is Gordon E. Moore. It's actually an observation of how the transistor number and the computer efficiency is varying, or how the transistor number will be increasing in every year. So according to him, the number of transistors per square inch on integrated circuits doubled every year. So this is basically the law. The speed and capacity of our computers increase every couple of years, and we will pay less for them. According to his concept, this was true, and it have been observed like this. As the number of transistors increased, the price was reduced, and there were competition between the companies to increase the number of transistors and reduce the cost of the computers. So Moore's law actually correlates the number of transistors and the corresponding benefits in computer technology. And this actually increased the speed and capability of our computers as we increase the transistor number every couple of years, and we will pay less for them. And the introduction of nanotechnology enabled wires and transistors to be smaller and smaller, and thus more efficiency was obtained. So basically Moore's law points to the fact that number of transistors per unit inch on the integrated circuits will be doubled each year. So this was the law that was proposed, and it had been true for a long time. But there is a suggestion by one of the famous physicists, Michio Kaku, that is the law will be breaking down at some point. So this law was valid because there was competition between the computer companies to reduce the price, to reduce the size, and increase the efficiency by increasing the number of transistors. For incorporating more and more transistors at a small range, they had to work with the nanotechnology and reduce the size. And after a particular period, we may be able to miniaturize these things to an atomic level, but beyond that, a miniaturization may not be possible. So now research is being done on molecular transistors, and hopefully we can go further and further lower in this particular scenario. So you should know what is Moore's law. Moore's law is just a statement or just an observation that have been true for a long time in the computer technology, that is regarding the number of transistors or a semiconductor device. And this is directly an after effect of the nanotechnology, or this is the impact of nanotechnology on computer technology, as it was possible to explore further into the smaller regime. We were able to devise more and more materials which are having very small size. So this is all about the introduction to nanotechnology. So we discussed what nanotechnology is, how it was developed, and its importance and various properties of nanomaterials, and about Moore's law, how its impact on computer technology. And in the next lecture we will be discussing about the synthesis of nanomaterial and biosynthesis of the green synthesis of gold and silver nanoparticles. And that's all. Thank you. And try to read more about nanotechnology and recent advances in nanotechnology. This is actually an important, interesting field, and don't miss out. Thank you.